Hello, we're looking to solve compound inequalities. They often come in the form of having two bounds on both sides of x. We solve them by solving for x on three parts: on the left side of the inequality, in the middle, and on the right side of the inequality. So for example, we want to solve the inequality -3 is less than or equal to 2x minus 5 is less than or equal to 5. When we set this up, we're going to kind of solve for x, taking our cues from what's happening to x in the middle. So for example, I want to add 5, but I have to add 5 everywhere. I get 2 is less than or equal to 2x is less than or equal to 10. Then I want to divide everything by 2. And now my middle piece is just x. And I get 1 is less than or equal to x is less than or equal to 5. And I write my solution in that interval notation, 1, 5. And that is how we solve compound inequality problems. The next thing we want to do is solve absolute value inequalities. And so to consider how we solve these, let's look at the origin of inequalities, which is the absolute value equality. If we want to consider the absolute value of 3 equal the absolute value of x equaling 3, and where those solutions happen, they occur at 3 and at -3, right? When I have an absolute value equality, like I do right here, I get two values, the -3 and the +3. Now, if we want to think what values of x satisfy the absolute value of x being greater than or equal to 3, right? We still get that 3 and -3 being answers. But what we want to consider is that when we have the absolute value, we can use the origin as like a mirror that is going to look exactly on the left side as it does on the right. So let's consider this case again. If I want my absolute value of x to be greater than or equal to 3, all of those values greater than or equal to 3 are to the right of 3, filling in this way. And if I want my mirror image around the origin, that would pull that over to this side, and that should make sense. If I think about -2, -2 has an absolute value of 2. That is not greater than or equal to 3, so I don't want those values. However, -4 does have an absolute value greater than or equal to 3, which again implies I want to fill in to the side. And that gives us that our inequality we solve from this are twofold. I get x has to be less than or equal to -3. Those are all those values. And x has to be greater than or equal to 3. Those are all the values here. The other direction of an absolute value we might want to solve is the absolute value of x is less than or equal to 3. Again, I can get the values of -3 and 3 as a possibility. What we want to do again is to consider the equals case and see what happens. If I think about 2 and 4, which of those has an absolute value less than 3? Well, of course, that's 2. That tells me I want to shade in all of these values. And because I want the mirror image of this, I want it to go on the other side. And of course, that should make sense. If I look at -2, the absolute value of -2 is equal to 2. And that is, of course, less than or equal to 3. So that should fit. This will give us the inequality of -3 being less than or equal to x being less than or equal to 3, that compound inequality we just solved. And so what this does is it gives us a way to solve absolute value inequalities. That if I see an absolute value of x being greater than or equal to k, I want to solve this by splitting it up into x being greater than or equal to k, or x being less than or equal to -k, as two possible ways to solve this. If I get x, the absolute value of x is less than or equal to k, I have one compound inequality of -k is less than or equal to x is less than or equal to k. So let's look at solving some of these. Again, we want to recall to solve any absolute value problems, we first need to isolate for the absolute value. And so here we see an absolute value that we want to solve, and we have a greater than case. Before we can split this up, I want that absolute value to be by itself. So I'm going to have to subtract 2 to both sides. And I'll get the absolute value of 2 minus 1 is greater than 7. And because we have this greater than case, I'm going to split this absolute value into being greater than 7 or 2x minus 1 being less than -7. And I have to solve them independently. So I'll add 1 to both sides. 2x is greater than 8. Divide both sides by 2. X being greater than 4. Here, I'll add 1 to both sides. 2x is less than -6. Divide both sides by 2. X is less than -3. And I want to write these in interval notation. So x is greater than 4. I have this. X is less than -3. That's my interval. But when I write these as a final answer, I want to put this interval farther to the left first. This interval is farther to the left. So I have -∞ to -3, union 4 to infinity, as that one case we saw on Wednesday. This would be my final answer, these two different intervals. When I solve the next one, the absolute value of 3x minus 4 is less than or equal to 16. Because I have this less than or equal to case, I get to split this up into a compound inequality. That -16 is less than or equal to 3x minus 4 is less than or equal to 16. I'm going to solve for x the same way we did at the beginning of this video. I'm going to add 4 to everything, get -12 is less than or equal to 3x is less than or equal to 20, divide everything by 3, get -4 is less than or equal to x is less than or equal to 20 over 3, and we can keep that in proper fraction. I have to finally write my solution. I get -4 and 20 over 3. And just some quick interval notes. 1, interval notation is always written from least to greatest. So if I have the interval I want, let's say from 1 to 4, like this, I will always write it like 1 to 4. Right? It is never written as 4 to 1. Right? We don't want to do that. This is always how we write it. 2, and we kind of saw this before, if we have multiple intervals, we want to write them from left to right in a number line sense. So if our solution, for example, has the intervals 1 to 5, -∞ to 0, and 6 to 10, and I want to write this as a final solution, I want to put the one furthest to the left first, union the next interval, union the final interval. And for all of these types of solutions, they will never overlap. Notice how from -∞ to 0 will not overlap with 1 to 5, will not overlap from 6 to 10. And so when we write them, we get a solution that is completely disjoint, where this interval and this interval and this interval have no common values. So we put the union in between them. Hope that's helpful. See everyone on Monday.